Hi friends, today I am going to deliver a lecture on introduction and constructional details of synchronous motor. First of all, what is meant by synchronous motor? Synchronous motor is a machine which operates at synchronous speed and converts three-phase electrical energy into mechanical energy. So this is nothing but the definition for synchronous motor. And this synchronous motor is always rotating at synchronous speed only. Synchronous speed has got certain relationship or a formula, as we already know that is ns is equal to 120 f by p. Ns is equal to 120 f by p. So here in this formula, ns is equal to 120 f by p, there are two factors or two parameters that can just change the speed. Here one is frequency and second one is number of poles. You know, frequency is the frequency of the supply or three-phase supply given to the synchronous motor as an input. But here P is the number of poles. Number of poles are already designed at the time of manufacture. So that is why number of poles are fixed. But frequency is the only parameter which can change the speed. But we know the frequency of the part or supply is 50 Hz frequency, 50 Hz. It is fixed. So since the frequency 50 Hz is fixed and the number of poles are already fixed, that means these two are constant. That means synchronous speed is also constant. So that is why synchronous motor is operated at the synchronous speed, that is 120 f by p. Since frequency is constant, so synchronous motor can also be called as a motor which is running at constant speed. So this motor always rotates at constant speed only, irrespective of loads. So load may be something, that means it may be a light load or normal load or it may be overload. So whatever the load is maybe, irrespective of the load, synchronous motor always rotates at synchronous speed. The speed of the motor is always tied to the frequency of the supply given to the input. That means the supply given to the input to the motor. Right? Already I told you, motor is a machine which converts electrical energy into mechanical energy. In synchronous motor, we give electrical energy in the form of three-phase supply to the armature winding, otherwise stator winding of the synchronous machine. So then it gives mechanical energy at the synchronous speed, always which operates at synchronous speed. So now, since synchronous motor is a constant speed machine, right? So it cannot be operated at other speeds because usually at synchronous speed only torque is developed in synchronous motor. If the motor is not rotating at synchronous speed, then there is no any production of torque. So that is a very important point we need to remember for the synchronous motor. So that is why synchronous motor is a constant speed motor irrespective of the loads out of synchronous speed. That means if it is not rotating at synchronous speed, then there is no development there is no developed torque in synchronous motor. Motor will fail to rotate and its finally slows down to and finally gets stopped. And the second point we need to just know about the synchronous motor is synchronous motor can be operated at different power factors. Power factors means lagging power factor, unity power factor and leading power factor. So there are three power factors in power system. One is lagging power factor, leading power factor and unity power factor. So now at these three different power factors, we can operate synchronous motor by simply adjusting the current flowing to the field winding of the rotor poles. Field winding of the rotor poles. Now this is what the main advantage of the synchronous motor. Second point that is with synchronous motor is it can be operated at different power factors. So that means synchronous motor is a constant speed motor operated at synchronous speed irrespective of the load, and it can improve the power factor of the system. Power factor of the system by simply adjusting the field current of the rotor poles, right? And the third point is here synchronous motors usually are salient pole type of motors. That means if we take a rotor is a salient pole rotor. There are salient poles in the rotor structure. So that is why synchronous motors are usually of a salient pole type of synchronous motor. The third point and final point that is very important thing is synchronous motor is not a self-starting motor. It is not self-starting machine. It requires some external means to start it, right? That external means can also be called as auxiliary means, right? Auxiliary means. So this auxiliary means may be in two ways. First way is by using induction principle. First way is by using induction principle. Induction principle. And second way is by using starting motor. By using a motor. You know, by using an induction principle or by using a special motor to start the synchronous motor, we can make the synchronous machine to be self-started, right? So these are the main points of the synchronous motor. Now I am going to just explain you what are the constructional details of synchronous motor. Here I have drawn two pictures. One is the stator and another is rotor. So stator is the stationary part of the synchronous machine and rotor is the rotating part of the synchronous machine. You know, if I am explaining here the construction details of the synchronous motor, it is same for synchronous generator also. As we already know that DC generator can be used as DC motor since their construction is same. Similarly here also for synchronous motor, synchronous generator or an alternator is used by simply giving three-phase connection or three-phase supply to the stator winding of the synchronous generator. So the constructional details of synchronous generator and synchronous motor both are same. So now here stator is the stationary part of the synchronous motor or machine. Rotor is the rotating part of synchronous machine. Actually this rotor assembly is just kept here inside the stator, right? Here there is a shaft on shaft. This entire rotor assembly is mounted. Now here I would like to explain you about stator. Stator has got here stator core. So this is called as stator core. It has an inner periphery. In this inner periphery we see that here there are stator slots. In these stator slots, armature winding or the three-phase stator winding is placed, right? So now this stator core is made up of a material called as sheet steel lamination. You know, sheet steel laminations means, for example, if you see a picture like this, three-dimensional view. Suppose here there are several sheets are there, right? These are all several sheets. These are laminated together so that it gives a stator core. So this is called as sheet steel lamination. So this stator is a core which is made up of a material called as steel or cast iron, but it is a laminated sheet, right? Laminated sheets. Why it is a laminated sheet? Because in order to reduce the eddy current losses in stator core, right? So here we have to take, or it is taken as a sheet steel laminated stator core, right? And here we see that there are the stator slots. Inner periphery of the stator core has stator slots. In these stator slots, three-phase winding is placed. We know that three-phase winding is nothing but the winding which has got, right, three phases, and each phase is having 120 degrees electrical angle, okay, between them or between each phase. So this is called as three-phase stator winding. Now this three-phase stator winding, okay, so is placed in stator slots. So that is why we can call it as stator winding also. So now this stator winding is made up of a material copper. So now this is a simple understanding about the stator of the synchronous machine. And now coming to this rotor. Rotor is the rotating part of the synchronous machine. Here we have several parts in this rotor. So these are the called as salient poles. Salient poles. These are the salient poles. Why it is called as salient pole? Because here these poles are simply looking like projected poles, projected out, projected poles. So that is why these are named as salient poles, right? So here these salient poles are having a winding wound around it, right? So this is called as field winding, right? So this field winding is wound around the pole core. This is the pole core of the pole, right? Around the pole core in such a way that the current flowing into this field winding must form alternate north and south poles. Alternate north and south poles. Here it is north pole and it is south pole, and it is north pole and it is south pole, right? So here we have to wound a field winding around field poles, right? In such a way that the current flowing through this field winding forms alternate north and south poles on the poles of the rotor, right? So now, what is the current? The current flowing through the field winding is called as a field current. So this field current can be obtained by simply connecting this field winding to the DC source. This is called as DC source. So when DC direct current is flowing through this field winding, right, through slip rings. Here in order to give DC supply to this field winding, here we have used slip rings. Slip rings are there. So these slip rings, through slip rings, we have connected we have connected this field winding to this DC source. So now through slip rings, DC, the direct current is flowing through the field winding. This field winding is connected in series, right? As I already told, these are connected in series. Okay, each winding of the pole is connected in series in such a way that they should form alternate north and south poles, right? So now here these are the salient poles only, because synchronous motors usually are salient pole type of machines, right? So that is why here I have specially drawn a salient pole rotor. Okay, so now these are the slip rings. Okay, so now here these poles are simply fixed on the here a steel cylinder, right? Circular steel cylinder is there. This is also made up of material steel. It is mounted in the circular steel cylinder, right? And here the DC source is basically in different forms. That means the DC source is given by either DC shunt generator or DC compound generator, right? Is mounted on the shaft. So here there is a shaft, so simply it is mounted on the shaft from this DC source. Okay, from this DC supply is given to this field winding. Okay, so this is something about the rotor of the synchronous machine. So this is all about the constructional details of synchronous motor. Right? In next video, we are going to see the principle of operation of synchronous motor. Thank you.